Hey guys, how you all are doing? I hope it's going good for you guys. So I'm back with another video of raw and unfiltered DSA. So today I'm gonna take a daily question from the LeetCode. So in the last video I took the two some question to get just my hands-on experience, and I know it didn't went very well, but okay, I mean that was easy. We are getting a medium question now called partition array according to given pivot. So let's try attempting this question, and let's see if I would be able to do it or not, and I mean let's see how it goes. So let me open up the problem, and okay, so the problem statement says you are given a zero indexed integer array nums and an integer pivot. Okay, we have to rearrange nums such that following conditions are satisfied. Okay, less than pivot appears before every element, greater than pivot. Every element equal to pivot appears in between the element, less than and greater than pivot. Okay, so got it. The relative order of the element less than pivot and the elements greater than pivot is maintained. So pi pj, where pi is the new position, pj is the new position of j element if I is less than j and both elements are smaller or larger than pivot, then pi is less than pj. Okay. So we have given an input 9, 12, 5, 10, 14, 3, 10, pivot is 10. Okay, so kind of I've got an idea what the problem statement is asking to do, right? So for example, we are given an array. Let me copy it up. What it is: 9, 12, 5, 10, right? So we are given the array, sorry, 9, 12, 5. Okay, I think I'm kind of new to this whiteboard, so not able to make much sense out of it, but yeah, I will still try, right? So 5, 10, right? And what next? 9, 12, 5, 10, 14, 3, 10, right? So 14, 3, 10, and then the array. Forget my handwriting. I mean not the handwriting, how I'm drawing on the whiteboard. So this 10 is our pivot element that is given. So we have to rearrange this array such that I mean, so let's say this is our array. We have to rearrange it such that the element which are less than 10 should appear before it. The greater than 10 should appear before, I mean after the 10. While the retaining the structure, we have to also see that their corresponding indexes are maintained. What I say about indexes is, for example, if I take element 9 and 5, right? So they both are less than 10. So this should appear in the order like 9 and 5, like this. They shouldn't appear like first 5 comes and then 9 comes, right? So the vice versa should not be true. The I and j indexes should be maintained. So for example, that's what is mentioned in the array, that in the question, that if I is less than j and both elements are smaller or larger, then pi should be less than j, right? So so here what would be our output, right? So if I say our output, so what it will appear? So first we will start 9. So 9 is less than 10, right? So 9, 12 is not less than 10, right? So here we can also think of how our approach will look like, right? So for example, instead of doing this, I can have two array. I am going with the brute force approach first, right? So one, I'm kind of planning to store two arrays. So one will be basically to store the lower elements, one to store the higher elements, right? About the pivot element, we can either store it in the lower element or we can store it in the higher element. So but for the simplicity, let's say we have one lower, right, lower array, it's empty, and then we have one higher array, right, that's also currently empty. Now we started with this 9, right? So 9 is less than 10, we have compared it, it will go to the 9, right, filled in. 12, now 12 is okay. So for the higher array, let's initialize it with the pivot element first, right? So we can kind of iterate through the array and we can find all the pivot element, and we can insert it in the higher array, because this will be the very lowest element, right? After that all the elements would be higher. Now or maybe we can kind of let's do it this way. Instead of inserting, we can do it while iterating in the array itself, right? Okay, now 9, let's go to 12. 12 is higher than I mean bigger than 10. So okay, beat, but I think let me read the question again. Okay, so the pivot should come first, right? Pivot should come first. So 953, okay, 10 12 10. So the relative order of the element less than and the element greater than pivot is maintained. For example, consider that pi is the new position of ith element I and j, and both elements are smaller, then pi should be less than pj. So what I'm thinking, I mean there is a corner case. So for example, if instead of 953, what if it was 5 9 and 3, right? So should the output will still be 9 5 3 10, or will it be 5 9 3? So every element less than pivot appears before every element. Okay, so if it's less, it will appear before, that's fine. The relative order of the element less than pivot and the element greater than pivot is maintained. Okay, so the relative order, for formally consider pi and pj, where pi is the new position of I, okay, and j is the new position of the j. If I is less than j and both elements are smaller or larger, then pi should be less than pj. So here it doesn't hold for 9 to 5. 9 is not less than 5. Okay, so new position of ith element, and okay, got it. So for now, I mean, since I'm not seeing any further clarification and I'm also a bit of confused, so let's take that this ordering is kind of maintained, right? So if kind of in the order in which the number appears in the array, in the same order kind of it will be given, we will be having the output, right? So let's say that 12 comes. So in that case, we first have to, so pivot element will be in between, right? So we have to initialize the higher array, right? So let's say we will do the initialization 10 10, since there are 2 times 10, right, pivot element. Now comes 12, so 12 is higher, right? So we will insert 12 in the higher array. Now comes 5. 5 is again less than 10, so it will come here. 10 we have already done. 14, now 14 is higher, right? So 14 will come here. Sorry, let me make it more like 14. Now come 3, so 3 is less, so here comes the 3. Then comes the 10, which we have already inserted. So now it becomes 2 array. Sorry. Right. So now what would be our final output? So our final output would be the lower plus higher, right? We just have to do lower plus higher, right? So this is the brute force approach that I'm thinking about. That so basically, if we see the time complexity, it's kind of sorry. So take the time complexity for this one. It will be O of n, since we are iterating over the loop. Actually, it's O of n plus O of n, right? Because first we are iterating over the array to find the pivot element, and then inserting it in the higher array, which can be further optimized. For example, we can keep a counter how many times that pivot element appears, right? And then we can kind of insert them in the higher array, so that way it will become O of n instead of O of 2n. So I think that's still fine. The overall, I mean, the worst, it will still become time complexity with O of n. The space complexity, right? Here, since we are using an array, right? So the total sum with lower and higher array would be O of n plus O of n. I mean, you can say the combined sum would be the n only, right? So the space complexity, since we are using an extra space, it will become O of n, right? So let's go ahead with this approach first, try to solve the problem, and let's see whether it passes through all the test cases that are given. All right. So, and forget about my Java syntaxes in the last video. I'm not sure if I'm going to face the same here as well. So okay, so let's go ahead with the size nums dot length, correcting my mistake from the last video, right? And let's take counter pivot counter equal to 0, right? This is just basically to ensure how many times the pivot appears, instead of iterating through the loop first time and then kind of inserting it into the higher array, right? And then let's say the array, right? So lower elements, and we will say new int, right? And higher elements equal to new int. Now okay, I still, since the last video, this array syntax using this square braces still kind of new to me, so forgive me. I'm doing the Google search using int array in Java. I'm just looking for the syntaxes, like how to do this push, right? So should I have to do it? Okay, I have to mention the size, but I don't want to mention the size initially. So can we do it empty array instead? Seems like okay. Student type array. Okay, this is how we can do allocating memory for 5 objects. Okay, it seems like we have to allocate the memory to the array. Fine. Got it. So you guys can comment me down what is the best way to do it. I mean, for now, since I can't go like thinking much about it, because we have a time limit also, right? I can't make it a longer video. So you guys can comment it down like what you guys use it and what is the best way, right? So I will also research it before coming into the next video. So let's initialize it with the size. So this basically makes our space complexity as O of n plus O of n. That will become basically O of 2n and eventually O of n only, right? So I have initialized it here. Let me just quickly check one more thing. Yep, I think all fine, right? So now let's begin the iteration. So for int I equal to 0, I less than size, plus plus I int current element is nums I. We will check if current is less than pivot, so lower LMs. Okay, now this is again kind of a bit trickier thing. I have to maintain two pointers in this scenario, right? And I don't want to do it. I mean we can do it, that's not the problem. It's just that I think there might be a better way to do it. So let me do this instead, using array in Java with push functions. Okay, I can do a array list, right? No man, I don't want to do okay, but how to return as does it works? Seems like it does. So got it, let me use it. I know this is a bit tricky. Array list of integer. I think, yeah, this is how we have to initialize. Lower LMs equal to new array list. I think that's fine. Yes, right. So then our next one, higher LMs equal to new right. So what I will do, lower LMs dot add current, or else if current is greater than pivot, then what I will do, higher LMs dot add current, and else. Now that means else the current is equal to pivot, right? So then that means I will just increase the counter of pivot. Okay, now we have to return. So what we will be returning, it will be like return lower LMs plus array of pivot counter, right, plus higher LMs. So this is what we have to return. So how to concatenate the array, right? So I will say, just let me just Google search it, concatenate array list with in Java. Let's see. Okay, so we have to do int stream dot concat. Okay, no man, too many things. To list dot streams, map to int. Okay, let's see. So it will be lower LMs, right, and it will become area of stream. So now for the pivot counter, right, how many we have? Oh, I think we can see if the array has this push front method. I mean, I am aware of the C++ in the vector B had this push back or push front, right? But I think it doesn't. So maybe what we can do instead here, right? For int I equal to 0, I less than pivot counter plus plus I, and then we will do lower elements dot add pivot, right? So this way in the lower elements, after adding all the elements, we will add 10 10, and then we will do here inside kind of, let's copy it down. Okay, seems good, but let's run it, and then if it seems good, then only it's good. Okay, as expected, we have some error here, compilation error expected. Oh, sorry, my mistake. But seems like, yeah, there is no errors. So let's submit it. Let's see if it throws any runtime errors or any cases are failing. Okay, I think we were overthinking about the problem. I think kind of it was correct only. So we got the runtime of 28 ms, but let me think if we can further optimize it. So the memory is like 171 MB that it used. So I think can we do something kind of a in-place conversion? Uh, Maybe in-place conversion, and we do it in a kind of a single iteration, right? So I mean, let me think. Let me first erase it. Okay, I mean, the better way is that we, sorry, let's take this here. So I will write down the input again, right? So we had array of, okay, I forgot. Let's go to the desktop. 9 12 5 10. So 9 12 5 10, right? 9 12 5 10 14 3 10. So 14 3 and 10. So what I think we can do instead, we can think of something like doing the in-place sorting. Now I'm thinking how we can do it. So there is one thing that also comes in my mind, is something called divide and conquer, right? So the divide and conquer is like we split the array into half, right? And then we try to process the element, like we again further reduce it to half, like dividing it into half every time until we get the last element. And that last element, like, then we start arranging the elements, right? uh, I mean, let me think of if something else we have. If for example, if we are iterating 9 12, we find 12 and we replace it, we see if it is uh, but for that we will need a pointer to this pivot element 10, right? Or rather we can do, I think divide and conquer seems to me to be a approach here. So for example, what we can do here in seed, right? So we have total of 3 6 7 elements. So we will divide it into half, right? So for example, 4 and 3. So let's say we divide it from here, right? And now what we have to do is that, so now after dividing it become 9, 12, sorry, 5, 10, right? And then so this is become our left, the another array will become 14, 3, 10, right? So now further we will divide, right? So it will be divided from here, it will be divided from here, and then we'll say, let's say 9, 12, right? And then another array will become 5, 10, this will become 14, 3 and 10, right? Now this will become further divided to 9 and 12. So let's see, sorry, 9, right, 12, and then it will become 5, become 10, it will become 14 and 3, and it will become 10. Now we have to kind of, so we have divided, right? Now kind of while merging and going backtracking, right, I think we have to merge it. So if we see 9 and 12, I'm not sure, so how we will do it? Yeah, we will compare each of them, right? So BC9, right, and BC9 is less than 12. No, ideally I think it should be something like we should be maintaining some left and right pointers. Okay, so I think we might be missing something. Let's little bit check the divide and conquer algorithm, right? Yeah, so be done 70, 20, 30, right? Be divided 4, 3, 70, 20, right? Done 30, 50, 60, 10, 40, 70, 20. Now while merging 70 and 20, we kept 20 first, 70 later on, 30 first, 50, and then while merging these two, while left is less than something like, we go through this array and we check while it's less than like 20 is less in all of them, right? We went here and then we went to 30, then we went to 50, and then we went to 70. Okay, let me just take a quick look. So this is the example of the merge sort. Can we achieve it here as well? So I mean, while merging 9 and 12, but here we have the pivot element, right? So it's like It becomes like a merge sort, but kind of a modified merge sort. But I'm not sure why we are doing it, because I think the time complexity for the merge. So I mean, if we see, right, the divide and conquer, it's kind of O of n by b plus n by b. Yeah, I mean the best case is still O of n log n, right? And our current approach here, this done. I mean, this does the thing in O of n only, which I think from the runtime point of view, I think it's better. But I think, I mean, I still think I'm missing something here which could have been done. Mm, okay, maybe let me look through the solutions also. Let's not waste more time here. Let's check the verified solution. So okay, it's not preserving the relative order. It's attempting to use quick sort style partitioning, but the approach disrupt the relative order. Fine, we didn't do that. Dynamic list. Okay. Hmm. Oh my god, they have used linked list. God save me. Yeah. Yeah, I think so. This is what we done. O of n and O of n. What is the another approach? Two passes with fixed array. We used dynamic list to build the three sections because we did not know initially how many elements. The flexibility, but there is extra space, correct, that we discussed. We will rearrange nums using only a single fixed size array instead. The challenge is knowing how to place each element of nums. Okay. We can perform an initial pass through nums to keep count of the number elements. Mm-hmm. Okay, I think this also makes sense. I mean, what makes sense? It's correct only. So it is to basically to count the numbers and divide basically to first count how many numbers are less than the pivot, how many of them are greater, right? And then you initialize the array and then you kind of reposition them out, correct? So for each, if array less I equal to num and increment. Got it. So I mean I can quickly explain you what this talks about, right? So I mean I'm not going to implement it right now because we have already seen it. I mean I know what it will be going to be about, and becomes pretty easier only, right? So if you take consider this array, right? Sorry, 9 10 12 15 10. So it says you first count how many numbers are less than pivot, right? So less than pivot, that if you count it becomes 1 2 3, right? 3. Then you count how many of them are equal, or you can, so basically you have to count just two of them. The third one you can always get by using the addition and subtraction, right? So if you count how many of them are equal, right? So equal is 2, so that means the higher are 3 plus 2 5, and 7 total of, we have 7 element, right? So 7 minus 5, that will become 2, right? Which is 12 and 14. Now it says that you initialize the array, right? So with the fixed size, right? So now since we know the size, so it will become new int of 7, correct? And then it says while going through the each element you maintain the counter, right? So it's like your start less idx will be 0, right? Your equal idx will be, so your equal idx will be basically 3, right? Or you can say like 3, so when the less is ending, like the lesser elements are ending after 3, so 0 plus 3 will become 3, right? And then the higher index, and that you will see, so it will become 3 plus 2 5, so it will be 5, right? So now it's like whenever you encounter a less element, for example 9, right? So if you encounter 9, you put it in the less index at position of the less index, then you do less index plus plus, right? If you encounter a equal element, you put the element at equal idx and then you do a plus plus, right? Similarly, if you find an element which is greater than p, but for example 14, you just put it at the place of higher index and then you do plus plus, right? And that's how it will get solved. Here the time space complexity get reduced, because now instead of using 2 array, right, we are using 1 array only of fixed size, while the earlier approach that we took here, right, this also kind of gives you the same space. But in future, for example, if the array numbers are growing, or for example, I mean, we can define a fixed size of array, right, to reduce the memory, right? For example, here we don't know how much the size would be, right? It's kind of undefined size. So rather than having a undefinite memory, we can, if we can get a definite memory in our uh, machine, right, that's more efficient eventually. So yeah, I think that's all for today's video. uh, I mean, it was not that much hard. I think we haven't encountered much syntax problem also, but I think yeah, it was a good learning as well for me. So yeah, that's it for today's video. I think you guys can comment it out on this thing, how you guys are using the arrays and manipulating the array in Java. I will go through the comments, I will check it out. And yeah, until the next video, peace out, see you guys in the next video.